going to clean my glasses because I can't really see. And I hope you've been having a good week. In these parts, it's been a very different week. Like, hey, Keenan Music, it's cool to have you on. Super awesome data, very cool. I hope you're having a good week as well. It has been different, just kind of taking care of some stuff, not getting a whole lot of sleep, and enjoying music theory along the way. Sometimes music theory and the abstractions of music make for a good week. So hopefully you're enjoying it and having a good time. We are in lesson 1 of this series, where just to kind of get some bearings here, we start with actually to really get our bearings here. I'm going to share this screen. Just as always, the easiest way to find the playlist, all of the content in the library, is at mycolormusic.com, which provides playlists for all of the content. So in the music theory course, lesson 0 establishes the context of why learn music theory, why do all of this, why it's important to understand the language of music and the underlying patterns and fundamental framework of all of these structures so that you can create your own art. And then lesson 1, really starting into that process of, okay, how can I understand these patterns? How can I wrap my arms and my head around this fundamental framework? It's the ability to see sound. That's what's been tripping us up as musicians and trying to understand the art of music, is to really learn the science of music theory. So in lesson 1, we get into seeing sound, not through the traditional lens of, diagrams, black and white dots, music notation, tablature, all of that, but it's using natural patterns of sight, color, to see the natural patterns of sound music. So with color music, we can actually bridge that gap between the visual and the auditory. And what we've been doing is, let's see if I can share that screen. What we've been doing is moving through the patterns of music, the fundamental patterns of music theory, to arrive at that aha of seeing sound. So so that's where we've been. We started seeing that the major scale, this is where we left off. The major scale is a natural pattern of whole step and half step intervals that we combine into different into patterns, and we can start on any key within the chromatic scale or any note within the chromatic scale to form 12 different keys. In the key of E, we can play whole, whole, and then half, whole, 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 half to play. Oops, let me do that again, because an interesting pattern actually shows up in this. We start with the square in the key of E. Here, looking at the key of E. We start with the square, whole, whole, to stay within that pattern of whole steps that are squares. And then from a G sharp to an A, we have a half step. And then from A, B, C sharp, D sharp, it's all whole steps within the pattern of circles. And then we do a half step to arrive at the E again. Starting on F, which is a circle, we have whole step, and then a half step to get into the squares. We stay with those whole steps until we do another half step to arrive at the circles again. So you can see it alternates back and forth. So already we're starting to see that, there's something going on here. There's definitely like this alternating pattern. There's definitely a sequence and a predictability to these patterns that seems to bespeak a logic that may be knowable, may be understandable, and not only something that we can grasp, but we can really master. And that's where we're headed into step 3 of seeing sound, which is to create the circle of fifths. So we are now into step 3. So we started with the chromatic scale, then we played the major scale. Now we're step 3 to create the circle of fifths. So using intervals, the major scale turns the chromatic scale into something more musical. So again, we played the chromatic scale, which sounds sort of aimless. We picked out a subset of notes using whole step and half step intervals like these to play a major scale. And by playing that same sequence of intervals starting on any note within the chromatic scale, we see that a predictable pattern appears, which is that we can play a major scale starting on any note in the chromatic scale to carve out 12 different keys in music. Okay, so that's where we're at. Using intervals, the major scale turns the chromatic scale into something more musical. Like magic, these intervals inject a sense of energy and movement into the notes you play. And by simply starting this pattern on each separate note, you can create a total of 12 major scales. It's awesome. But for as good as the major scale sounds and how prominent it is in music, there's an even more powerful pattern, as it turns out, one that outshines the major scale by far in terms of its beauty, elegance, and overall influence. That is a typo. I'm just going to underline it for further reference. And this pattern is called the circle of fifths. So in fact, compared to the spark of magic that you hear in the major scale, the circle of fifths is more like a high voltage electrical powerhouse full of intense and dynamic force. And the reason why is because this pattern is essentially a super mega major scale on steroids, comprised of all 12 scales wrapped into one. Indeed, it's remarkable how it's built and the way it functions. So to show you what I mean, let's look at exactly how the circle of fifths is constructed, starting with the C major scale as the first segment in this pattern. And in the process, you'll also learn why it's called the circle of fifths. So I want to jump into a couple of comments here before we continue. Super awesome data. I got the stickers and the new wheel right here. Very cool. I'm glad to have you have music theory as a tangible thing that you can hold in your hands. Always kind of trips me out. It's always amazing that I can hold music theory in my hands. So I love it. Key music. This week I figured out a new way to record on my piano that's way better. Very cool. Progress. Jumping into the creative process. That's the thing. There's so many steps to making music that even just the logistics of how can I send electrical impulses from this device to that device is a challenge. Technically, how to move your fingers on the keyboard or the fretboard or whatever instrument it is another challenge. And then even just knowing why you should place your fingers in the different positions is another challenge. So it's all these layers of kind of obstacles or hurdles that you need to get to experience that aha moment of just pure joy and expression and being in the moment. And so to be able to tackle those is a beautiful thing. Key music. I plugged the piano directly in my laptop while I was running GarageBand. Very cool. That's awesome. I'm going to be excited to hear what comes of this connection and what you create. That's awesome. So looking at the major scale, we're gonna use the major scale to create the circle of fifths, which traditionally is seen has this aura of mystical, magical powers, and it does have powers in the sense that it's electrical powerhouse, like I say, that informs all of the relationships and the energetic harmonic relationships between notes, but it's actually very simple how it's constructed. So let's give it a look. So the C major scale. So as you already know, this scale is a subset of the chromatic scale, formed by a sequence of whole steps and half steps that sound good together. Really good, in fact. So again, major scale. And because of how it's capped by C notes at each end, this pattern feels distinctly complete too. So we're using the C major scale as our example here. As if it were a single unit of compatible pitches, that is, self-contained and independent, like an island unto itself, you might say. Do you know what I mean? As a group, these 8 notes just sound so whole. Yet when you look carefully, you'll see that the scale actually lives within a larger ecosystem of sorts, as only a small part of a bigger, overlapping web of patterns. It's wonderful, really. And the way it works is this. When you split the major scale down the middle, you'll see that it's made up of 2 equal halves, where each half is an identical group of whole steps, which are represented here by a W, followed by a half step or an H like this. So looking at the C major scale, we have C, whole step, D, whole step, E, half step, F. And then we skip a whole step to G, whole step, A, whole step, B, half step, C. So 1, 2, 3, 4, dividing line, 5, 6, 7, 8. Is the first half, is the second half. You can hear it. You're like, oh yeah, the major scale is divided into these two halves. When you see it like this, it's like, oh yeah, that's interesting that whole step, this extra whole step down the middle, is a dividing line or like a perforation that you could split the major scale into two separate halves. All right, so continuing here. So do you see? It's easy to recognize when shown this way, especially with the squares and circles, which help to highlight this repeating pattern. So to highlight that point, again, we were talking about how the first part, the whole steps, separate the squares, and then you have a half step into the circles, and then you have a half step that brings you back to the squares. So it's like this dividing line separates the circles, part of it, it's in the circles part. But when you see that it's really what we're looking at here, let me show this in another way, which helps to simplify the pattern. What we have here is we have this whole half, which is basically like, I'm going to kind of draw it with an angle. So it starts with squares, but it ends with a circle. See how it's rounded on that end? And then we have another one that starts with a rounded end and then ends on a square, if that makes sense. So I have starts with a square, ends with a square, and then there are circles in between. So you can see, oh, there's like a symmetry involved here. There's almost like a geometry, or there's starting to be a recognizable pattern that we can use to make sense of what we're looking at here. So let's continue with the narrative. Okay, so, and it's this repetition, this duplication of intervals that explains why the major scale sounds so nice, because it's more than just a random sequence of notes, but one that exhibits a natural symmetry as well, and specifically what geometry nerds call translational symmetry. We are getting into some geeky territory here, and this geekiness will pay off in dividends. So for context, the translational symmetry differs from the other more common types that everyone knows, such as reflectional symmetry and rotational symmetry. So to illustrate the distinctions between them, the following shows how each of these function using the letter P for pattern as an example. Okay, so we're gonna break these types of symmetry down. So here on the left, reflectional symmetry, also known as mirror symmetry. This type occurs when the reverse of an object or pattern is reflected over a line or mirror. So that's when people talk about symmetry, that's often, at least in my mind, what kind of comes to mind is reflectional symmetry. But there are other types of symmetry. So this next one is rotational symmetry, also known as radial symmetry. This kind happens when an object or pattern remains unchanged but rotates around a fixed point. So rather than having a mirror, it's rotating around this point. And then translational symmetry, one that was less known to me, and I imagine is the most obscure here, is translational symmetry. So this type of symmetry occurs when an object or pattern remains unchanged, but is translated or repeated at intervals along a path. So like radial symmetry, it's unchanged, but it's repeated across a path. So another type of symmetry, and as you're going to see, all three types of symmetry come into play here. Music theory is wonderful. So each type of symmetry is unique, as you can see, and as we advance, you'll find that all three appear in music. So what I just said there. But for now, we'll start with translational symmetry and the fact that the intervals of the major scale are repeated, which is interesting, like I said, and even marvelous. But what's even better is the way this repetition reveals a special link between scales, where some of the same note patterns appear in multiple keys, and specifically the fact that each half of a given scale straddles two keys in particular. For example, when you look at the C major scale again, you can see that this pattern is comprised of two parts, C, D, E, F, G, A, B, C. And when you sort through all the other major scales, you'll find that another one, the G major scale, shares four of the same notes, G, A, B, C, but as the first half of that scale instead. So this is the C major scale, and this is the G major scale, and these notes appear in both C major and G major. So let's play that. C major, C, D, E, F, G, A, B, C. The G major scale is G, A, B, C, D, E, F sharp, G. So G, A, B, C shows up in both patterns, in both keys. So get it, this group of notes is identical. In C major, it's the second half, while in G major, it's the first, but the pattern is the same.